What's up, future civil engineers? How you doing? I'm your instructor, Daryl J. Mendros Balbin. In this video, I will solve sample problems 4 to 7 in head losses in pipes. Calculate the head loss in a 250 mm diameter pipe, 500 meter long, when water flows at 115 liters per second using A. Darcy-Weisbach formula with F equal to 0.02, B. Manning formula with N equal to 0.012, and C. Hazen-Williams formula with C equal to 100. When Q expressed in cubic meter per second is given, the Darcy-Weisbach formula is HF is equal to 0.826 FL times Q squared over D raised to 5. Substituting, F is 0.02, L is 500 meters, Q is 0.0115 cubic meter per second, D is 0.25 meter. Solving for HF is equal to 11.19 meters. Next, when Q, expressed in cubic meter per second, is given, the Manning formula is HF is equal to 10.29 N squared L times Q squared over D raised to 16 over 3. Substituting, N is 0.012, L is 500, Q is 0.115, D is 0.25. Solving for HF is equal to 15.93 meters. And finally, when Q expressed in cubic meter per second is given, the Hazen-Williams formula is HF is equal to 10.67 LQ raised to 1.85 all over C raised to 1.85 times D raised to 4.87. Substituting, L is 500, Q is 0.115, C, which is the Hazen-Williams coefficient, is 100, and D is 0.25. Solving for HF is equal to 16.65 meters. The loss of head in a 1200 mm by 600 mm pipe conveying water is estimated at 0.04 meter per meter length. What is the discharge? F is equal to 0.032. Discharge Q is equal to AV. To solve for velocity V, we will be using the Darcy-Weisbach formula. HF is equal to FL over T over D times V squared over 2G. But since the pipe is non-circular, we need to solve for D first. The pipe is rectangular with dimensions 1200 millimeters by 600 millimeters. To solve for D, that is for R, wherein R is the hydraulic radius, which is equal to A over P, where A is the area, P is the wetted perimeter. The area of the rectangle is 1.2 meters times 0.6 meter. The wetted perimeter, we assume that water is flowing full in the pipe, meaning the whole perimeter of the rectangle is wetted. and that perimeter is equal to 2 times 1.2 meter plus 0.6 meter. So the numerator has a unit of square meter, and the denominator has a unit of meter. Cancel meter. The hydraulic radius R is in terms of meter, and that is equal to 0.2 meter. Therefore, D is equal to 4 times 0.2, and that is equal to 0.8 meter. Next, we use the Darcy-Weisbach formula and substitute the values. HF from the problem is 0.04 meter per meter length. F is 0.032. L is 1 meter since we're considering per meter length. D is 0.8 meter, which we just computed. V is unknown. G is 9.81 meter per square second. Solving for velocity V, that is equal to 4.43 meters per second. Now finally, we're ready to solve for the discharge Q. Substituting, the area of the rectangle is 1.2 meter times 0.6 meter, and the velocity is 4.43 meters per second, which we just calculated. Therefore, the discharge is equal to 3.19 cubic meter per second. Final answer. Oil with density of 950 kilograms per cubic meter and kinematic viscosity of 0.00002 square meter per second flows through a 30 centimeter diameter pipe 100 meter long at 5 meters per second. Absolute roughness is 0.00194 meter. A. What is the Reynolds number? B. What is the friction factor? And C. What is the total head loss? When U is given, Reynolds number RE is equal to VD over nu. Substituting, velocity is 5 meters per second, the diameter is 0.3 meter, and nu is equal to 0.00002 square meter per second. Solving for RE, that is equal to 75,000, and that is greater than 4,000. Therefore, the flow is turbulent. And since it is turbulent, for the friction factor, we will be using the Colebrook equation. And substituting, our E is 0.00194 meter, our D is 0.3 meter, our RE, which we just computed, is 75,000. Solving for friction factor F, that is equal to 0.0339. And finally, for the total head loss, HF, since we have a friction factor, we will be using the Darcy-Weisbach formula. Substituting, our F, which we just computed, is 0.0339. Our length is 100 meters. Our diameter is 0.3 meter. Our velocity is 5 meters per second. And our G is 9.81 meter per square second. Now solving for total head loss HF, that is equal to 14.40 meters. Glycerin with a specific gravity of 1.26 and absolute viscosity of 1.49 pascal second flows through a 600 millimeter diameter pipe at 85 liters per second. A. What is the Reynolds number? B. What is the friction factor? And C. What is the critical velocity? Reynolds number Re is equal to rho Vd over mu, wherein V is equal to Q over A. Substituting, the density is equal to 1.26 times the density of water, which is 1,000 kilograms per cubic meter. The velocity is equal to discharge over area, wherein the discharge is 0.085 cubic meter per second. The area of the circle is pi fourths d squared, wherein the diameter is 0.6 meter. Multiply that with the diameter, which is 0.6 meter, all over mu, which is 1.49 pascal second. Solving for Re, that is equal to 152.53, which is less than 2000. Therefore, the flow is laminar. And for laminar flow, the formula for friction factor is equal to 64 over Re. Substituting the computed value of Re, we get F equal to 0.420. And finally, to compute for critical velocity, we have to remember that for critical flow, Re is equal to 2000. Using this formula for Re, we substitute our values. Our Re is 2000, our density is 1.26 times 1000 kilograms per cubic meter. Critical velocity is unknown. Our diameter is 0.6 meter. Our mu is 1.49 pascal second. And solving for Vc, critical velocity is equal to 3.94 meters per second.